In this presentation on real numbers, we are going to discuss certain word problems on LCM and HCF. The first question we have is, find the largest number which divides 245 and 1037, leaving the remainder 5 in each case. So let us suppose that the number we are finding, that is B. The number we are finding, the required number, that is equal to B. So what is given to us is that when this B, it is divided by 245, we are left with remainder 5. It means by the Euclid's division lemma, we are having that 245, that is equal to, there is some quotient Q, and the remainder we are left with, it is 5. So what this gives us, when we solve this value, we obtain that BQ is equal to 240. We subtract 5 from the both sides, we get BQ is equal to 240. So what this implies is that if we divide B by 240, we will obtain some Q. So this implies us that B is divisible by 240. Similarly, it is given that 1037, when it is divided by the number B, then the remainder left, it is 5. So we are saying the required number B, it is the largest number which divides, we are having this number over here, 240. We have obtained this result, that we are interested in calculating the largest number B which divides 240. And from this second condition, we are having the number 1037. So from this condition, we are saying that it should also divide 1032. So we are interested in calculating the largest number B which divide both these numbers, and this is basically the definition of the HCF. We are trying to find a number, the largest number, which is factor of both these numbers. So we are saying the required number is basically the highest common factor of these two numbers. So to calculate the HCF, we are going to calculate the prime factors. So if we calculate the prime factors of 240 is divisible by 2, we will get the remainder, the quotient is 120. 120 is again divisible by 2, we will get the quotient as 60. This is again divisible by 2, we will get the quotient as 30. This is again divisible by 2, we will get the quotient as 15. 15 is now divisible by 3, so we will obtain the quotient as 5. So we are saying that 240 we can write, that is equal to 2 raised to the power 4. 2 over here, it is 4 times, 1, 2, 3 and 4 times. Then we have the terms multiplied by 3 multiplied by 5. Next we are talking about the number 1032. It is divisible by 2, it is even number. The quotient we are left with, it is 516. It is again divisible by 2, the quotient is 258. It is again divisible by 2, the quotient is 129. Now this number 129, it is not divisible by 2, but the sum of the digits, it is divisible by 3, so it is divisible by 3. So when we divide this number by 3, we obtain the quotient as 43. So we are saying that the prime factorization of 1032, it is 2 raised to the power 3 into 3 into 43. Now we have to calculate the HCF of these two numbers. So we are, first of all, we are writing the common factors. So the common factors, we have one common factor is 2 and the other common factor we have, it is 3. And the lowest power of these common factors, for 2 it is 3, for 3 it is 1. So when we multiply these terms, the answer we obtain, it is 24. So we are saying that 24 is the required number which when divided by both these numbers will leave the remainder 5. Next is find the largest number which divides 129 and 545, leaving remainder 3 and 5. So suppose we are saying that the required number be B. Then we are saying by Euclid division lemma, 129, when we divide it with b, we will have some quotient q, and it is given that the remainder left will be 3. It means that we can write it in the form 129 is equal to bq plus 3. So this implies us that bq is equal to 126, and this implies us that b divides 126. Similarly, we are talking about the second case. We are saying 545. When it is divided by this number b, we have the remainder, it is 5. We can write it in this form, that 545 is equal to bq plus 5. And this value of bq we obtain from this, it is 545. It means b is divisible by 545. Now we are interested in calculating the largest number which divides both 126 and 545. It means that we are interested in calculating the HCF of these two numbers. So the prime factorization, if we look at, we are saying the one number we have, it is 126. It is divisible by 2. The prime factorization we have, it is 63. The quotient we have, it is 63. 63 is divisible by 3. The quotient we have, it is 21. This number is again divisible by 3. The quotient we obtain, it is 7, and this 7, it is itself a prime number. Similarly, the prime factorization of 540, we have 2 is the factor, the quotient is 270. Again 2 is the factor, the quotient is 135. Now 3 is the factor, we are saying the quotient, it is 45. Again 3 is the factor, the quotient, it is 15. Again 3 is the factor, the quotient, it is 5. So what we obtain from this is that the prime factorization of 126, we can write it is 2 into 3 into 3 into 7, that is equal to 2 into 3 raised to the power 2 into 7. And for 540 we have, it is 2 into 2 into 3 into 3 into 3 into 5. So we are having the prime factorization in this form. Now we have to calculate the HCF of these two numbers, and we know that it is the product of the common terms with lowest power. So common terms we have over here, they are 2 and 3, and the lowest power corresponding to it, lowest power of 2, it is 1, and lowest power of 3, it is 2. So we obtain that the HCF, that is equal to 2 into 3 raised to the power 2, that is equal to 18. So we are saying that 18 is the required number which divides 129 and 545 and leaves the remainder 3 and 5 respectively. In this question, we have to find the largest number that will divide these three numbers, 398, 436 and 542, and leaves the remainder 7, 11 and 15. So we are saying, let the required number, that is the largest number we are talking about, let that number be b. Now it is being given that this b, when divided by 398, it leaves the remainder 7. So by Euclid's division lemma, we have 398, that is equal to bq plus 7. So from this, what we obtain is that bq is equal to 391. So what this implies is that b divides 391. Next we have the number 436. When this number is divided by b, we have some quotient q, and the remainder left, it is 11. So we get bq is equal to 425. It means b divides 425. The third number is 542, and we are saying we can write 542 is equal to, it is when it is divided by b, we have some quotient q, and the remainder left, it is 15. It means that bq, from this term we can obtain that bq is equal to 527, and this implies us that b divides 527. It means b divides 527. So we have to find the largest number. Now our question becomes that we have to find the largest number which divides 391, 425 and 527. So the largest number, that is factor of all these numbers, that will be the HCF. So we are saying the required number is HCF of these three numbers. So to find the HCF, we are going to write the prime factorization. So for this number 391, the first prime factor of this number 391, that will be 17, and we can obtain that 391, we can write it in the form 17 into 23. For this second number 425, the prime factors we have, the prime factorization we can obtain in this form, that it is 5 raised to the power 2 into 17. And for this third number 527, we can obtain the prime factorization as 17 into 31. So the HCF of these numbers, the common factor we have over here, it is 17. This is 17 and 17. Except for this, there is no common factor over here. So we are saying that the HCF of these three numbers, it is equal to 17. Hence we are saying the required number is 70. Now the next question we have is that two tankers contain 504 and 735 liters of milk respectively. So we are talking about two tankers are there. One contains 504 liters of milk and the second contains 735 liters of milk. We have to find the maximum capacity of a container which can measure the milk of either tank an exact number of times. So suppose we are saying that if we start measuring the milk in these tanks with a container that is having the capacity of 1 liter. So what will happen in this case? We are saying we have two containers are there and we are measuring it with the 1 liter container. So we need to measure this 504 times and we have to measure this 735 times. The second case we have is, suppose we are measuring the capacity of these containers with a 2 liter container. Then we have to find the maximum capacity of the container. So we are saying that we can use 1 liter container, but it is not the maximum capacity container that we are talking about. So we move on to the 2 liter container. So if we use 2 liter container, we can measure the capacity of this first container that is having 504 liter of milk. It can measure it in 250. If we have to measure it 252, use that container 252 times, but we cannot measure the milk in this container having 735 liters of milk. So this 2 liter container is not going to work. Next we move on to the container whose capacity is 3 liters. So if we use this 3 liter container, we are saying it can measure 504 liters. We have to measure it 168 times, and to measure 735 liters we have to use it, or it can measure it in 245 times. We have to measure it 245 times. Similarly, if we move on to the next container, say we are talking about the 4 liters container, then what we will have, it can measure the milk of 504 liter container, but it cannot measure the milk of 735 liters container. Next, if we move on to 5 liter container, it cannot measure the milk of 504 liter container. It can measure the milk of 735 liter container. Similarly, for 6 liter container, we have the case of 7 liter container. If we move on like this, we have to find the container having the maximum capacity. It means we are interested in the containers of this kind. 1 liter container can work, 3 can work, then this 7 liter container can work. We have to find the largest number which can measure the milk in both these containers. It means we have to find the largest number which divide both these values. And when we are saying the largest number which divide both these values, It means we are talking about the HCF of these two numbers. We have to calculate the HCF of these two numbers. So to calculate the HCF, we are going to calculate the prime factorization. So first of all, for this number 504, it is divisible by 2. The quotient we get, it is 252. It is again divisible by 2. The quotient we obtain, it is 126. This is again divisible by 2. The quotient we obtain, it is 63. This number is divisible by 3. The quotient we obtain, it is 21. This number is again divisible by 3. And the quotient we obtain, it is 7. So we are saying that the prime factorization of 504 we obtain in this form. Similarly, for the second number 735, it is divisible by 5. Then the quotient we obtain, it is 147. This number, it is divisible by 3. The quotient we obtain, it is 49. This is divisible by 7. So the prime factorization in this case we obtain, that is 735. We can write it in this form. So HCF of these two numbers, the common factors we have, it is 3 and 7, and the lowest power we have, it is 1 for both these numbers. So the HCF we have, it is 21. So it means that the 21 liter container, it can measure the milk in 504 liter container. It can measure the milk in 735 liter container, exact number of times, and this is the largest number. So we are saying the capacity of the required container is 21 liters. Now the next question we have is, an army unit of 612 members is to march behind an army band of 48 members in a parade. The two groups are to march in the same number of columns. What is the maximum number of columns in which they can march? So we are saying that there are 612 army members and 48 members in this band. So suppose they are moving in a single column. So how many rows will be there? There will be 612 rows of army member and army men, and 48 for this persons from the army band. Now suppose they are moving in two columns. We look at this situation in this way. We are saying they are moving in two columns. Now how many rows will be there for the persons having the army we are talking about? They are moving in two columns. This is column 1 and this is column 2. Now there will be 306 rows. 1, 2, 3, 4, 5, like this. There will be 306 rows in which we can arrange these army persons, and there will be 24 rows in which we can arrange the persons from the band. So in this case we are saying when there are two columns, so we have 306 rows of army person and 24 for the band. Suppose they are arranged in 3 columns. So if we are arranging them in 3 columns, then how many rows and columns? There will be 16 rows in which there are the persons from the band, and there will be 204 rows from which there are persons from the army. We are talking about this case. Next, if they are arranged in the 4 columns, so we are saying that there will be 12 rows in which the persons from the band will be there, and there will be 153 rows in which the person from the army will be there. So we are saying if we are using the 4 columns to arrange them, we will have the situation in this form. If we are talking about 5 columns, so we cannot arrange 612 persons in 5 columns because 612 is not divisible by 5. Similarly, we cannot arrange 48 persons in 5 columns. Next, if we are talking about 6 columns, we are saying if we divide 612 with 6, the quotient is 102. and for 48 the quotient is 8. So there will be 8 rows for band persons and 102 rows for army persons. For 7 columns, we cannot arrange 612 or 48 persons in 7 columns because these two numbers, they are not divisible by 7. Similarly for 8, this 612 is not divisible by 8, but it is divisible by 48. So we are saying what we are interested over here is we are trying to find the largest number over here which divides both the values 6, 1, 2 and 48. And this is the definition for the HCF of these two numbers. So we are saying the maximum number of columns that we can have, that is equal to the HCF of the number 6, 1, 2 and 48. Now if we calculate the HCF of these two numbers, for 48 we are saying it is divisible by 2, and the quotient we have it is 24. It is again divisible by 2. The quotient we have it is 12. It is again divisible by 2. Quotient is 6. It is again divisible by 2. The quotient is 3. So we are saying the prime factorization of 48 we have it is in this form. Then prime factorization of 6, 1, 2 we are saying it is divisible by 2. The quotient is 306. It is again divisible by 2. The quotient is 153. It is again divisible by 3. The quotient is 51. This number is again divisible by 3. The quotient is 70. So prime factorization of 6, 1, 2, it is 2 raised to the power 2 into 3 raised to the power 2 into 70. So the HCF of these two numbers 6, 1, 2 and 48, that will be given by the common factors we have over here. The common factors are 2 and 3, and their lowest power of 2 it is 2, and for lowest power of 3 it is 1. So we are saying the HCF we have, that is 2 raised to the power 2 into 3. The answer we obtain it is 4 into 3 is equal to 12. So we are saying that the required number of columns is equal to 12. Now the next question we have is Ravi and Shikha, they drive around a circular sports field, and Ravi takes 16 minutes to take one round, while Shikha completes the round in 20 minutes. If they both start at the same point at the same time and go in the same direction, how much time will they take to meet at the starting point? So to understand this question, we are considering this case over here. We are saying there are two persons, Ravi and Shikha, and they have started from the same initial point. They have started driving from the same initial point around a circular sports field, and after 16 minutes Ravi will complete one round. So we are saying the first round we are talking about, Ravi takes 16 minutes and Shikha takes 20 minutes. So we can understand this situation in this way, that after 16 minutes what will happen? We are saying Ravi has started from this point, and after 16 minutes he will reach again this point. Ravi has completed this round, while Shikha will complete the round in 20 minutes. It means Shikha is still behind Ravi. Now what will happen after 20 minutes? We are saying after 20 minutes now Shikha has reached this initial point over here, and Ravi has moved further to this point. So now at this stage both of them have completed their one round, but look at this initial point over here. When Ravi was at initial point, Shikha was not at the same point. Now when Shikha is at this point, Ravi is not at this same point. Now what we have to find is that after how many rounds they will be again at this same point. So now suppose we are talking about the second round. We are saying after Ravi will complete the second round after 32 minutes, Shikha will complete after 40 minutes. So situation after 32 minutes, it will be like this, and situation after 40 minutes will be like this. We are saying after 32 minutes Ravi will complete his second round, and after 40 minutes Shikha will complete her second round, and Ravi will be ahead of Shikha, but the distance between them, that will decrease. So again, in the third case we are saying, next case we are considering, when they will complete their third round, Ravi will complete after 48 minutes and Shikha will complete after 60 minutes. Then fourth round we are talking about, Ravi will complete after 64 minutes, Shikha will complete after 80 minutes. Then we are talking about the fifth round. We are saying, look at this condition over here. When Shikha is completing her fourth round, 80 minutes have been passed, and Ravi takes 80 minutes to complete the fifth round. Ravi will take 80 minutes to complete the fifth round. So if we are calculating this value in this way, what we can see, that after 80 minutes, Shikha would have completed 4 rounds and would have reached the same position. And after 80 minutes, Ravi would have completed 5 rounds and would have reached the same position. It means that they both will meet at the starting point after 80 minutes. Now, what is another way to calculate this is, so we are saying that what we are calculating over here, what are these numbers? Ravi takes 16 minutes. So we are saying that these are the multiples of 16. It is 16, 32, 48, 64, 80. These are the multiples of 20. The common multiples that we will obtain over here, the common multiple of both these numbers, that will tell us when they will meet at the initial position. And the minimum or the lowest of these common multiples, it gives us the required condition that after how much time they will meet for the first time. So we are saying that in this question, the required number of minutes, that is basically given by the LCM of 16 and 20. So in place of manually calculating these values, we can directly calculate the LCM of 16 and 20. The factors of 16 we know, it is prime factorization, it is 2 raised to the power 4. For 20 we have it is 2 raised to the power 2 into 5. So LCM of both these numbers, it comes out to be 80. So what we obtain is that both will meet at the starting point after 80 minutes. Next we have is, in a school there are 2 sections, namely A and B of class 10. There are 30 students in section A and 28 students in section B. Find the minimum number of books required for their class library so that they can be distributed equally among the students of section A and B. So what is given to us in this question is that the books are to be distributed equally among the students of section A and B. So if we consider the situation in this form, we are talking about this case. What this data is representing? This data is representing, we are talking about section A. This is corresponding to section B. How many students are there? There are 30 students in section A and 28 students in section B. Now we are saying that if we are giving books per student, we are giving 1 book per student, then how many books we require? There are 30 students in this section, then the total number of books required, that will be 30 in this case. And for section B, the total number of books, it is 28. Next we are saying books per student, if we are saying this, that is 2. We are distributing 2 books per student. Then how many books will be required for section A? That will be 60. How many books will be required for section B? That is 56. If we are distributing 3 books per student, then the total number of books required for section A is 90. The total number of books required for section B, it is 84. So these numbers 30, 60, 90, these are basically the multiples of 30. These are the multiples of 28. Now what we have to find is, we have to find the minimum number of books required for their class library so that they can be distributed equally among the students. So we need a number over here. We want to find how many books should be there so that both the students of these section, they get the equal number of books. So that will be basically the number of these books must be a multiple of 30 as well as of 28. So we are saying we are interested in calculating a number that is multiple of both 30 and 28. So the required number we have, it is the required number that will be the least common multiple. We want to find the minimum number of books. So we are saying that will be the least common multiple of 30 and 28. Now the factors of 30, they are 2, 3, 5. Factors, the prime factorization of 28 we have, it is 2 raised to the power 2 into 7. So LCM of these two numbers, 28 and 30, that is the product of the prime factors with highest power. So prime factors with highest power means we are saying 2 raised to the power 2 into 3 into 5 into 7. So on solving this value, we'll obtain the answer as 420. So we are saying the required number of books is 420. So this situation we can also see over here. We are saying that if we continue in this way, suppose we are distributing 10 books per student. We are having 300 books for section A. We will have 280 books for section B. So continuing in this way, what we will obtain, that if we have 420 books, we are saying if we have 420 books, then each student of section A will get 14 books and each student of section B will get 15 books. That is, there should be 420 books in their class library.